Hello all, welcome back to my YouTube channel all about VLSI. In our previous session, we have seen how to design our UVM sequence, UVM sequencer and UVM sequence item, and we have also introduced to the Testbench architecture of what we are going to build. And in this particular video, we are going to start with the development of UVM driver, UVM monitor and UVM agent. So let us try to develop them. So first of all, let me declare the class driver, which extends my UVM driver, and it is also a parameterized class, so I'm going to pass it as a parameter. That is my transaction class handle. I'm going to pass it now. So let me register it. So I've registered my driver class. Now I also need to declare the virtual class, and I also need to declare my virtual interface handle inside my driver. So because driver needs to communicate with the design, right? So we need to declare the interface handle as virtual dff underscore inf. So in our previous video, we haven't discussed about interface file at all. So first what we will do is we will first declare the interface class also. So I've declared my interface handle. So I've declared my interface handle as VIF. This is my interface handle which I've declared, and let us write down the constructor function new string name is equal to driver and UVM underscore component parent. Okay, and super dot new of name comma parent. Okay, and followed by end function. So I've declared my constructor now. So let us write down the build phase function void build underscore phase UVM underscore phase. So in the build phase, what are we going to do is we are going to use our in the build phase we are going to use our config db for getting our virtual interface handle. So how to use our config db, we have already seen this. If not of UVM underscore config underscore db hash VIF hash virtual dff underscore inf, this is the interface instance which we are expecting, followed by get this comma empty arguments because it is a receiver side, and VIF is a handle name and the argument which we are expecting is VIF. Okay, so if we are not getting this particular thing, what we are going to do is we are going to display UVM underscore info get underscore type. Let us use a fatal method UVM underscore fatal no interface virtual interface is not received. This we are going to display. So this we are going to display when we are not getting our interface, and followed by end function. Okay, yes. So this is our build phase which we have written, and now after build phase we are going to write down our run phase. So run phase will be written in the task task run underscore phase UVM underscore phase. Let us declare the transaction class handle dff underscore txn, and within a forever begin block we are going to use our TLM port handles. So sequence underscore item underscore port dot get underscore next underscore item of txn. Okay, so using the TLM port handles, I'm going to get my transaction from the sequencer. So it is a built-in TLM port handle. We don't need to declare it. Okay, and next what we are going to do is after receiving that particular transaction item, we are going to put it into the copy it into the interface. So how to copy it? VIF dot d is equal to txn dot d, and we are going to use sequence underscore item underscore port dot item underscore done. Sequence underscore item underscore port dot item underscore done, so that our sequencer will come to know the driver has received the data. Okay, now let me print the transaction, and let me print a message UVM underscore info get underscore type underscore name $s format f driver driven data d is equal to percentage d comma tx dot txn dot d. Okay, so this is what we are writing here, and followed by UVM underscore low. Okay, and followed by end task. So this is our driver class. So in the driver class, first we have declared our driver class, and we have registered our driver class, and we have created the interface instance, and we have used our new function. And in the build phase, we are trying to get the interface instance. If we are not getting the interface instance, we are going to print the fatal message. And in the run phase, we are basically getting the transaction from the sequencer. And after getting the transaction from the sequencer, we are giving it to the virtual interface. We are copying it to the virtual interface, and using the sequence underscore item underscore port item done, we are acknowledging our sequencer that we have received our data. Okay. So this is our driver class which we have developed. Now let us try to develop our monitor class. So first let me declare it class dff underscore monitor, which extends my UVM underscore monitor, and let me register it UVM underscore component underscore utils dff underscore monitor, and within a new function new string name is equal to dff underscore monitor is my class name, and UVM underscore component parent. So super dot new of name comma parent, and followed by end function. Now, so within a build phase, this monitor also needs the virtual interface instance, right? So first of all, let us declare that instance virtual dff underscore inf VIF is the interface instance. The interface, yeah, this is our interface handle, and the instance where we will get it from the top. So we are going to use a build phase for getting that particular thing. You for getting the interface instance from the top. So function void build underscore phase UVM underscore phase of phase. So super dot build underscore phase of phase, and here we are going to use the config db if not of UVM underscore config underscore db hash dff underscore inf virtual dff underscore inf, and we are going to scope resolution operator get this comma empty arguments comma our handle name is VIF, and the variable we need is VIF. Okay. And if we are not getting this, I'm using a fatal message. This is a message I'm printing, and followed by end function. Now, so in the run phase, in the run task, run underscore phase UVM underscore phase. Now here what are we going to do is we are going to first of all declare the transaction class handle txn, and forever begin. So at passages of clock, we are going to observe the data passage of VIF underscore clock. Tx is equal to, let us create the instance of our transaction class handle. Txn is equal to dff underscore txn type id create txn comma this. And after creating the instance of this transaction class, so what are we going to do is we are going to copy the driven data from the interface vif.d, and also the expected output exp q underscore exp, that is the output expected output from the interface vif.q. Okay. And we are going to use monitors analysis port dot write. This is our write method which is present in the monitors analysis port, and we are going to send the transaction. So this will be received by our reference model as well as our scoreboard. Okay. And followed by tick UVM underscore info. Let us print it UVM underscore info get underscore type underscore name dollar is formative monitor observed the data percentage d, and output of design, that is q, is equal to percentage d comma txn dot comma txn dot d comma txn dot q underscore expected So this we are going to print it after receiving the data and followed by end task and followed by end class. Yes. So this is the code for our monitor. So what we have done, we have just created the class for our monitor, which by extending from the UVM monitor, and we are registering the UVM and we are registering the monitor class. And after that, we are declaring the virtual interface handle. And within the new function, we have written the new function. And in the build phase, we are trying to get the interface instance from the top. And after that, we are going to use a run phase where we are going to copy the data as well as the output which is present in the interface into the local copy, that is our transaction class. And using the monitors analysis port, we are going to call the function that is write function, and we are going to pass the transaction and which is being received by our reference model as well as our scoreboard. And we are going to print the observed data as well as the data which we are getting from the uh, design, and we are going to end the task and end the class. So this is our monitor class.